Now, what is VPH? VPH means voltage phase, a line through which mobile phone operates. Also an important line for mobile phones, right? In this diagram, that there is a line coming out from DC to DC IC and which going to the PMIC, also with the other sections like network, light, LCD, Wi-Fi, Bluetooth, etc. This line coming out from DC to DC IC and going to the PMIC, also going to the other section like network, light, LCD, Wi-Fi, Bluetooth. This line called VPH. After VPH, PM creates buck line, also LDO. After this, CPU and eMMC activate. After that, your phone turning on. So this is the whole process. In this whole process, VPH is the main line, main voltage line. Why we use VPH instead of VBat? What is the weakness in VBat? Earlier in mobile phones, we use VBat power. I mean battery power. When you connect the battery to the battery connector, battery power delivered to the PMIC, also network, light, LCD and other section. After the PM create output and CPU and eMMC IC activate. The biggest problem in this was as soon the shorting in any area, shorting coming to the battery connector directly. Suppose this network IC, network section, a 4G PA means power amplifier, was short. So shorting directly coming to the battery connector. For that, due to shorting, drain or battery swell, these kind of problems. Right now, in next generation phone use DC to DC IC BQ24295. It's a DC to DC IC, DC to DC IC, a variant. Many type of DC to DC IC. Basically, DC to DC IC use are designed to convert a source from one voltage to another. It's used in portable devices like mobile phones, laptops, LCD, LED TVs and many more devices. DC to DC IC in mobile phones convert VBus line to VPH line, a source from one voltage to another. Convert it VBus voltage to VPH. Also, it creates step up voltage or step down voltage. For example, if you had input in 5 volt and your requirement in output is 10 volt, 9 volt, 8, 7. So DC to DC IC take input 5 volt and create output as you want output in a require you want. If you want 2 volt, 2.5 or 3 volt, it's convert to this voltage. That's why we call is source from one voltage, convert a one voltage from to another. In mobile phone also DC IC working as a charging IC. That's why we call also charging IC. It's also called PMI IC, sub power, charging IC and BQ IC. This is all variant of DC to DC IC in mobile phones. Get back to the VPH. VPH is always voltage. Now, what is always voltage? Always voltage means it will available in all sections where VPH connected, near the PMIC or network section, light section, in other sections. Right? It does not matter your phone is off or on. In your mobile phones, they need two type of powers, one from battery and another from charging. When you connect to the charger, DC to DC IC convert the VBus voltage to VPH. Charger in off condition, also with battery or without battery, VPH is available. You can check easily near the PMIC, also other section where is VPH going, or connect the VPH, light coil, network section, PM section, power IC section. For example, a phone come to you in dead condition, check 1 or 2 step. Third step is mostly you check VPH is made or not. For this, you connect a charger in dead phone. Without battery, you can check near the PMIC capacitors, input capacitors with multimeter on voltage mode, VPH is made or not. After that, you can process next steps. So that's why VPH is always voltage, every time available whenever the battery or charger connect. If you connect the charger DC to DC IC, switching with coil made VPH. After that, PM IC activate or create buck lines also LDO lines after the CPU and eMMC activate. Process of VPH, DC to DC IC. Before we that, one thing, please listen. I will give you all complete information, each and every IC, but according to the section. For example, in a charging section, when charging section start, I will give you all information of BQ IC, all variant, or PMI IC, you can say charging IC, all information, all variant IC, right? But according to the section, when light section start, I will give you light IC, all light IC information with data sheet, how to read and how to repair or use. For this, you just subscribe the channel and share the video. If you had any problem, just comment it. Now I will explain all this to you through schematics and diagram. Also draw a block diagram so that you can understand easily. So I am opening a Redmi schematics. I am opening a Borneo. On Borneo, I am opening a Redmi schematics. Now a question might come to your mind. I always teach you only on Redmi diagram because it's easy to available. All model and easy to available. This is the reason I'm only teaching in Redmi diagram. Now you have to understand one thing, that whenever you have to repair it according to the IC number, PMIC number, power IC number, PMI IC number, or CPU number. Which part you repair only according to the IC number. You never have to repair phone according to the model. Suppose a model come to you, Motorola model XYZ. You never repair a phone according to the model or company. You always repair according to the which IC installed. For example, a Motorola model come to you, but the diagram or hardware solution is not available. So which has installed PMI 632 IC, right? For this, you can find this IC in Borneo, also in Google, which model had installed same IC, because many times it will happen that the diagram of the phone which has come to you for repair is not available. For this, you have to know the IC number, search in Google or Borneo which model is available. So then select the other model and diagram, then you can repair your phone looking the other phone diagram, right? I'm also teach you how. When I will upload the video of reading the IC of data sheet, any IC you can read data sheet, how I will tell you how you can repair phone looking the another phone diagram. Now get back to the VPH. First, how to trace in schematics. First, find the charging connector in layout. Go to the layout and find the charging connector, and here is charging connector. Just copy it and paste in schematics, right? Next, now zoom. After that, find the VBus line. Now here is VBus. Just copy it and next. Now the VBus going to the OVPIC, right? So this is a OVPIC. I'm already taught you in lesson 1 and lesson 2, right? Before I'm telling you about OVPIC, I will draw in block diagram this line. For this, back to the diagram, you can see there is a IC and there is now a connector, a line emerge from connector to the OVPIC, right? Now back to the schematic. OVPIC means over voltage protection IC. Now this IC work like a fuse. Its function as such that if suddenly there is excess voltage in this line, this IC open itself like a fuse. Suppose in this line had a 5 voltage, but suddenly this line had 7 volt in input. So this IC open itself to secure the motherboard or other circuit. That's why we call over voltage protection IC, OVP. IC will open. How to bypass it? You can bypass easily. Now first, how to check this capacitor. If you get 5 volt, check this capacitor. Just copy the capacitor and paste the layout and find the location. On location, you can check if you get 5 volt here also, then OVP IC will be okay. Otherwise, OVP IC will open. To bypass OVP IC, you can just take a jumper from this capacitor to this capacitor, connect the jumper, so you can easily bypass the OVPIC. In lesson 1 and 2, I will tell you many more things about OVPIC in detail, so you can check out the details and go to the lesson 1 and lesson 2. I will also tell you complete information about OVPIC, what type of OVPIC. I'm giving you all information, but in charging section. OVPIC also a charging IC, because this IC related to the charging section. So I will give you all information about in charging section. Right now, just copy it another side and next. Now this line goes to a IC. Which IC is this? PMI 632. Now I will draw in block diagram this line going to the OVPIC to PMI IC in 3 points, 1, 10 and 11 print, right? So VBus line connect with the 1, 10 and 11, right? Here you can see 1, 10 and 11. From here to 1, here is 9, here is 73 volt and here is 81 volt. So it's a 81 volt IC. Now get back to the schematics. As soon this line goes inside the PMIC, you get 5 volt on USB MID cap. Here this cap you get 5 volt. In lesson 1 and lesson 2 I'm already told you about MID cap. You can call also VMID, right? PMID. We will draw in block diagram this cap. This is a PMID cap, right? If you get 5 volt here, this whole line completely okay, right? If you get 5 volt on PMID cap, if you get it, that means this line connected to the IC and this line completely okay. Issue in other side. Now after that PMID cap, a line comes out of IC with connected boot cap and a coil 28, 29, 30 pin connected with the boot cap, also connecting with the coil. Another side boot cap connected with the 40 number pin. A line comes out from this IC, connect with the capacitor, we can call boot cap, also a coil. This is a switching coil, right? You must have seen that the most of the capacitor have value on one side and other side it will a beep or attach with ground. If you check with the multimeter, on one side you get value, right, and other side connect a beep or 00 ground, because they connected with the parallel line. But the boot cap connect with the both ends connect with the this IC, one connected with the switching line and other connected with the boot cap print 40 number, right? Also in boot cap you get one side 4 volt and other side 8 volt, or if you add 3 other side you get 6 volt, a voltage difference from both ends. Now this boot cap, this switching coil, also in this IC there is a MOSFET, right? The MOSFET switching with boot cap and coil. After that this line increase ampere. Just a second, I will tell you. This line goes to the mobile as other phones, other sections, or PMIC become a VPH, right? I will tell you in schematics. Now you can see here the boot cap connected with the coil, the boot cap connected with the 40 number pin, also other side connected with the 28, 29 and 30 number pin and connect with the coil. After the switching MOSFET, boot cap and coil, power goes to the mobile phone other section, we can call VPH power, right? After that a line goes back to the PMI IC or DC to DC IC, we can call VPH power or V system. We will draw in block diagram. Get back to the again DC to DC IC, we can call VPH or V system. In MediaTek we can call V system. After this line goes back to the IC, another MOSFET. In this IC converted this voltage or this line to the VBat line, or we can call a charging out line. Just a second, I will show you. So this line converted a MOSFET. When this line goes back to the IC, converted with the a MOSFET and get back to the VBat. This line goes to the VBat. VBat means on a battery connector. We can call also charging out line, right? I will show you in schematics. When this line get back to the 55, 56 and 57 number VPH power. Also we can call V system in MediaTek, right? V system in MediaTek, in Qualcomm VPH power, right? After that a line called VBat power goes to the right. Just copy the and paste it in layout, and next you can see this is the whole concept of how VPH made, how DC to DC IC work, or DC to DC IC generate VPH, right? Now if your VPH is not forming also a VPH line short, how to solve this problem, right? I am explaining you in block diagram. For this I will tell you a very easy way. For this you have go to a VPH coil first, a VPH coil. Just remove this coil, or you can say open the coil with hot air gun and keep it on another side. Now both ends are open, one from here and one from here. If you remove the coil, both ends are one from here and one from here, right? If you don't understand, this is a coil. If you remove it, the both ends are open, right? One side connect with the IC and other side going to the mobile phone sections like PM, power IC section, network section, etc., right? Now this side connected with the mobile phone section and this side connected to the charging IC, or you can say DC to DC IC. Now check one by one both ends with multimeter which line had a problem or short or leakage. Suppose this line had a problem. For this, if the charging IC side short, right, then replace the charging IC. Check the boot cap also, right? Also input voltage in this IC. Mostly if you change this or replace this IC, 100% your problem is solved. But on the other hand, if problem on this side, so this side goes to the PMIC, also many sections is mobile phone, right? For this, if you get a thermal camera, if you suppose this side had a problem. Now if this had a problem, you need a thermal camera, right? If you don't have a thermal camera, you will solve a problem with rosin method. How? I will tell you little bit. Just a rosin flex, spread the rosin smoke on entire motherboard which VPH is going. After that, apply the 4 volt 5 ampere in this point, right here. In this point, which part is melt first, that part is short. Mostly in cases a cap was short, but sometime a IC also had short, not a DC to DC IC, because this side open. I'm saying PMIC. Mostly cap in any section short, right? After that, network PA was short. After that, you can find easily where part is melt first, that part is short, right? We will make a special video for shorting, leakage or minor shorting in coming time. So we will give complete detail on this video. Now let's talk with VPH. Now let's talk if VPH is not made in your phone. For this, you try to replace boot cap, charging IC or VPH coil. Your problem will be 100% solved. Hope you like volt on one side.